Here I need to transact a TR. Then in the driver, what I need? I need a mailbox and I need a interface. That is virtual interface. Why virtual interface is required? Anyone? Hello.
Virtual interface is dynamic.
See, through the interface, we are going to send the values to DOT. So interface is definitely required. But why virtual interface? As I have already said, interface it is static in nature. I can't use directly interface in the driver. Driver it is a class. Class means it's dynamic in nature. So that's why I am just using a virtual interface. Virtual interface means it is just pointing to interface. And virtual interface it is dynamic in nature. This is also interview question. Why virtual interface? Again, interface it is static in nature. Driver it is dynamic in nature. So we cannot use static instead of dynamic. We are going to use virtual interface. It is just pointing to interface. Okay, so again, I have to make sure that this virtual interface is same for monitor as well as driver. So here I have to pass this interface as an argument to driver. As an argument through any function. Okay, so virtual interface here same should be used for driver as well as monitor. So transactor tier, then virtual FIFO INTF, let VIF. Okay, and then mailbox name, let I am writing driver D1. Okay, so function new, let okay, here function new mailbox name is driver1, then FIFO interface VIF. I am passing those two as an argument through any function because I have to make sure that driver generator is using same mailbox, driver monitor is using same interface. So this dot D1 equal to D1, this dot VIF equal to VIF, then end function. This is one way. Let you are just say, no ma'am, I am going to use the static mailbox. Then you don't have to pass the mailbox as an argument. So this part I don't require. Okay, so now interface part completed. Now the main function in the driver. Task run. Okay. So first I have to wait reset is equal to 0. Then I have to drive the signals. Okay. So here I can add task run begin forever. Why I am writing forever? Because see, in the generator let it is running for 40 times. I have to make sure that whenever generator part is completed, after that driver should come out of the loop. So it's up to you. You can either write here repeat 40 because generator is generating 40 values, or you can write forever begin, and you have to make sure that whenever generator is generating the values, after that driver should stop driving. So okay, that part will check later. Here I am just writing repeat 40. Why I have written repeat 40? Because generator is generating the values for 40 times. So repeat 40 begin. So I have to first get the values from the generator. So here D1. Okay. See here I don't have to write static mailbox D1. I can directly use here my generator class is okay. Generator class, then scope resolution operator. Their mailbox name is G1.get. Understood? See, this scope resolution operator is used whenever you are using any static variables. So here I am writing that inside the generator class, whoever variable mailbox is G1, from that mailbox get the values. Either this way, or if you are using this way, this manner, then you have to write here D1 dot get transactor. Okay, so this is if you are using static keyword. Now I get the values, then I have to wait for reset is inactivated. So wait VIF dot reset equal to 0. That means I have to wait for reset equal to 0. That means reset is deactivated. Okay. After that, if you want, you can give a delay at the rate posage of VIF dot clock. This delete is again optional. It's up to you. 1 posage delay is given. Okay, so next you have to pass the signals. Okay, so now what is the my clocking block path? So clocking block path, I guess it is in the mode port. Mode port name is drive dot clocking block name is driver CB. Okay, so now VIF. Okay, so it is VI. Okay, what is my interface name? VIF. See, interface name is VIF. So now go to interface. In the interface, go to mode port drive. Inside the mode port, go to clocking block driver CB. Now inside that clocking block, whatever the variable, write enable. That is equal to transactor dot write enable. So understood this. This is how I am converting pin level to packet level to pin level. Understood this part, all of you? Go to interface VIF. Inside the interface, go to this mode port. Inside the mode port, go to this clocking block. Inside the clocking block, whatever the signal write enable. This is the signal I am getting from the generator. Assign this signal to this signal. So if you are not using clocking block, you have to write in this manner. At the rate postage of VIF dot clock, VIF dot write enable equal to TR dot write enable. So all of you understood this part? Please respond, guys, whether you are getting it or not.
Yes, ma'am. Yes, ma'am.
Okay. So now when I should pass this signal should be passed only when write enable equal to 1. If write enable equal to 0, then do I have to pass this signal? See, whenever write enable equal to 1, then pass write FIFO related signals. But if write enable is equal to 0, I don't have to pass it. Okay, so here I can write if transactor dot write enable. So if this signal is equal to 1, then only assign those values. If write enable equal to 0, then I have to check whether read enable equal to 1 or not. So if read enable equal to 1, I have to pass the signals related to reading FIFO. I don't have to pass this signal. So this part is done inside the driver. Okay. So the write enable, then I have to pass the data in. So VIF. Okay. Then I have to pass the full signal. Okay. these signals all are related to my write enable. Let you want to pass these signals after 3 clock cycle. Then here you can give 3 clock cycle delay. Now I have to pass the read related signals. So transactor.read enable, if read enable equal to 1, so here I have to check the full signals also, because once I start reading, my full signal may not be 1. Okay, so this is the output. See, this output signal, it is again optional. You can capture inside the driver or you can't capture, it's optional, because output signal we are definitely going to capture inside the monitor. Here I have to take the full signal also. And I have to check the valid signal also. Why I have written full signal and empty signal here? Because once the FIFO is full and I start reading, then FIFO will go to empty. So this full and empty is affected reading and writing in both operations. So that's why I'm writing inside the read operation as well as inside the write operation. If it is not required, then you can not write it. Okay. So valid is equal to t-valid. So this is completed. I have read enable, let out, empty, full, valid. I have written all the signals. Okay. Now here let I want to display what are all the values. I can call transactor dot display driver. Then end task. Then end class. Okay. So this part is important part. Any code, you have to decide, okay, this part is important, because here if you are doing any mistake, then driver will not send the data properly to duty. You are not going to get any valid output. Okay. So guys, this is up to for today class. I'll be sending this part. Okay. And with this, I'll be sending the code link also in EDA playground where it is written. Okay. Up to driver, I have explained. Just go through this. Okay. If I'm sending, then there are so many extra things written. Okay. No problem. Okay. That code I'll send once I'm completing this thing. But before that, just whatever I have explained today, just go through these things. Next class, I maybe take tomorrow or day after tomorrow. There I'll be explaining the monitor scoreboard part. Okay. Okay. And one more thing, guys. Even if you know the things, but still you should know how to write these test plans from scratch. You go to any project. If you are doing